Welcome. So in this video, we will cover all the numericals which are given in the book Outlines of Dairy Technology by Sukumar. So there are total 19 numericals which are there in the big book, and we will learn how to solve these numericals quickly. These numericals are very important from the competitive exams point of view and are being asked in the written examination which is conducted by various cooperatives in India during their recruitment process. So let us solve these numericals one by one. So here first numerical is given in chapter 1. Name of the chapter is market milk. It is at page number 55, and the problem is on standardization of milk. So we know that in simple terms, standardization means adjusting the fat and SNF percentage of milk to a desired level so as to meet the legal requirements or other requirements which are prescribed. I'm again repeating, standardization is defined as adjusting the fat and SNF percentage of milk to a desired level so as to meet the legal requirements or other requirements which are prescribed. So first problem is how many parts by weight of 40% cream and 3% milk must be mixed to make a milk testing 5% fat. So this type of numericals are being sold by using Pearson square method. So in this we are making a square. On the upper left hand side we are writing the fat percentage in one material, and on the bottom left corner we are writing the fat percentage of the other material. So 40% cream, here we are writing 40% cream, and here 3% milk. And how much of 40% cream and 3% of milk to be added to have final milk with fat having to have milk of fat having percentage 5%. So we will write the desired level of fat percentage in the middle, and then we will subtract the larger number from the smaller number, that is smaller number from the larger number. So 5 will be subtracted from 45. 5 will be subtracted from 40, we will have 35, and here 5 will be subtracted from 3 to have 2. So 2 parts of 40% cream has come, and 35 parts of 3% milk has come. So we will be mixing 2 parts of 40% cream and 35 parts of 3% milk will be added to have total 37 products of the parts of the final product that will have 5% fat in it. So this way, so this is all calculations are on weight basis. So this way we are solving this numerical by Pearson square method. So here it's 40% milk of cream to be mixed with 33% milk to have 5% fat in the final mixture. So using Pearson square method, cream to milk ratio is coming as 2:35. So we have subtracted smaller number from the larger number. So here 5 minus 3 equal to 2, and here 40 minus 5 equal to 35. So 2 parts of cream and 35 parts of milk to be mixed to have 37 parts mixture having 5% fat. So this way we are solving such type of problems. Let us see another problem which is there on the page 55 to 55 and 56. So here question is how many kg each of 28% cream and 3% milk are needed to make 500 kg of mixture testing 4% fat. So again in this also we will make a Pearson square, and then in the here we will write 28% cream. So this is 28% cream. How much of 28% cream to be mixed with 3% milk to have final 500 kg of mixture testing 4% fat. So for the desired level of fat percentage we'll write in the middle, and again subtracting smaller number from the larger number. We have 28 minus 4 here 24, and 4 minus 3 here it is 1. So 1 part of 28% cream and 24 parts of 3% milk to be mixed to have total 25 parts of the mixture. So this total 25 parts is corresponding to the 500 kg. So now since we are given the quantity also, if you want to calculate the kg of 28% cream, that will be equal to 1 divided by 1 total divided by 25 into total final mixture given is 500, so it will be 20 kg, and here it is has come 20 kg, and how much milk is required, that will be equal to 24 divided by 25 into 500, that is equal to 480 kg. So this can be calculated by subtraction method also. 500 minus 20, that will be the remaining for milk, that is 480 kg of milk to be mixed and 20 kg of cream to be mixed to have 500 kg of 4% fat milk. Okay, so we can prove here also that we can check that our calculations are correct or not. So 4% of 500 is 20 kg and 28% of 20 is 5.6 kg, and fat from milk, it is coming as 14.4 kg, and total fat is again 20 kg. This means our calculations are correct, so hence proved. So obvious that the total fat will be same. So 14.4 is plus 5.6 is expected to be 20 kg as per our calculations. So this we have proved that our calculations are correct. Okay, now let us see the third numerical from the book. So this numerical is also on standardization. So in this problem we have to prepare toned milk from buffalo milk and SMP, and we have to calculate how much SMP and water that is required so as to have toned milk of 3% fat and 8.5% SNF. So we are given 1000 kg of whole buffalo milk containing 7.5% fat, 9.8% SNF, SMP 0.5% fat and 96.5% SNF, and how much of SMP and water that is required to have toned milk containing 3% fat and 8.5% SNF, that we have to calculate. So in this type of problems we are framing three equations. One is fat equation, other is SNF equation, that is a fat balance, SNF balance, and the weight balance. So this is the total weight balance. So since we have to calculate amount of water and SMP that is required, so we will take that, assume that water to be required as W and SMP to be required as S. So total weight balance will be 1000 of the whole buffalo milk is given plus weight of the water W plus weight of the SMP, that is S. So total weight balance will be like this. And if you want to write the fat balance, so 7.5 from buffalo milk, 0.5 from SMP, that will equal to the total that is 3% which is required in the total volume of toned milk, that is 1000 plus W plus S. So this is fat balance. Similarly we will write the SNF balance, that is 1000 into 9.8 plus 96.5 into S from SMP, that is equal to the total weight of the toned milk into 8.5% SNF that is required. So this is 8 SNF balance, and we have now three equations, that is we have weight balance, we have fat balance, and SNF balance. So this way we are framing three equations for this type of problems. And now since this is calculations, to make easy calculations we have to remove these decimal points. To remove these decimal points we can multiply both the equations by 2. So if you multiply both by 2, here it will be 15, here it will come 15 into 1000 plus S into 1 equal to, so 2 into 3, here 6 will come. So here total 15,000 plus S equal to 6,000 plus 6W plus 6S, simple, and 6W plus 6S will come as 9,000. So this is first equation. We have fat equation we have made simpler. Now to make SNF equation as simpler, again we have multiplied by fat balance by 2. So here SNF balance also we are multiplying by 2. Here in this case we'll have multiplied by 2. Here it will be 19.6 into 1000 plus 193 into S is equal to the total weight into, if we do 2, this is will coming 17. Okay, so from this equation we have 17W minus 170S equal to 2600. Okay, so this way we have removed the decimal point from the equations so as to make calculations easier. Okay, now we have two equations. So we have to eliminate one array variable. So here we are eliminating w first. So 6w is coming as 9000 minus 5x. So here as we know that to eliminate we have to multiply this equation by 17 and this equation by 6. So if in this way we will have 102w equal to this much, and 102w here in this case equal to 15,600 plus 1056s. Okay, so now if we equate them, because these two are equal, so these two will also be equal. So if we equate them, we have the s value, that is the amount of SMP that is required, is equal to 120.42 kg, and amount of vector that is water that is required. If you put this value in this, we will have w is equal to 1399.65 kg. So SMP that is required is 120.42 kg, and water that is required is 1399.65 kg. Okay, so this way we have calculated how much SMP and water is required to have final toned milk using buffalo milk and SMP and water to have fat percentage of 3% fat and 8.5% of SNF. So these type of problem to be solved by framing three equations. One is that fat balance, SNF balance, and the total weight balance, and we will have two equations, and we have to remove one first one variable, and then after having one variable answer, then we can derive the second variable answer from it by putting in the in one of the equation. Okay, now see the fourth problem. Okay, so this problem is from chapter 3, cream, given on page number 127 to 128. So here these two problems are on skimming efficiency. So let me first define skimming efficiency. It is skimming efficiency of a cream separator refers to the percentage total fat from milk recovered in the cream. That is how much fat we are recovering in cream from the fat that is there in milk. That is known as skimming efficiency, or efficiency of skimming by the cream separator. That is how much fat recovered in the cream from the total fat in milk. That is nothing but the skimming efficiency. And the higher the fat percentage in milk and or greater the fat loss in skim milk, the lower is the skimming efficiency, and vice versa. So lower the fat percentage in milk or lesser the fat loss in skim milk, higher will be the skimming efficiency. Okay, now these two numericals, how to simple way, they are very simple numericals. So you calculate the first you see that how much fat that have been recovered in cream. So this problem is 4 is milk is given, fat percentage in milk given, and then in total cream that has been obtained, and the fat percentage in cream is given. So you calculate first fat content in cream, that is 52.5 divided by 100 into 14.1, that is coming 7.4025 kg, and then you calculate total fat in milk, that is 7.5 divided by 100 into 100, that is equal to 7.5 kg. Now skimming efficiency simply divided by that is fat recovered in cream, that is 7.4025 divided by fat that was there in the milk into 100, that is coming 98.7% efficiency. So skimming efficiency is coming as 98.7%. Okay, now the same numerical similar way that we are giving here also we are giving milk and the fat percentage in milk, and cream is given, and how much fat percentage cream, that is also given. So we can first calculate the fat content in cream, and then fat content in milk, divide fat content that has been recovered in cream divided by fat that is there in the milk into 100, that will give you skimming efficiency. So here 45.5 divided by 100 into 10.3, that is coming as 4.6865, and then 4.8 divided by 100 into 100, that is coming as 4.8 kg. So 4.6865 divided by 4.8 into 100, that is equal to 97.6%. So here skimming efficiency is comparatively lower as compared to this in the first program. So this way we can easily calculate the skimming efficiency. As the name indicate, that is how much efficient is the cream separator in skimming the milk, or how much that cream that has that fat in percentage that have been recovered in cream from the total fat percentage in milk. That is nothing but the skimming efficiency. Okay, now let us come to problem number 6, which is again on standardization of cream. It is given in chapter 3 on page number 136. So this problem is on standardization of the cream. That is, we are given 1000 kg cream testing 50% fat. How much skim milk testing 0.1% fat must be added to obtain 40% fat in the standardized cream? Okay, so we are giving cream with 50% fat, and skim milk is given of 0.1% fat, and we have to have 40% fat in the final cream. Okay, so this type of problem again we will make use of Pearson square. So here 50% fat cream and here 0.1% fat skim milk, and in the middle we will write the desired fat percentage in the standardized cream, that is 40%. And here if we subtract 40 from 50 we'll have 10. If we subtract 0.1 from 40 we'll have 39.9. okay, so 39.9 parts of 50% fat cream to be mixed with 10 parts of 0.1% skim milk to have total 49.9 parts of the standardized cream. Okay, now this is to solve this problem very simply. We can say that there are the parts ratio, that is parts, that 39.9 is to the parts of skim milk, that is to 10. The proportion of their parts will be equal to the proportion of their quantities. So 1000 kg cream is given, and then we have to calculate amount of skim milk that is required. So say skim milk is required is S kg, and if we keep these two ratio, because these two ratio will be equal, so if we equalize them we will have the quantity of that is skim milk that is required. So 10 by 1000 into 39.9, that is, it is coming as 2250.6 kg approximately. So to standardize 1000 kg of 50% cream to 40% fat cream, add about 251 kg of skim milk to the cream, we will have standardized cream of 40% fat. So this type of numerical again to be solved using Pearson square method. Okay, now let us see the 7th problem, which is from chapter 4, butter, page number 136. So in this problem we have to calculate amount of salt to be added to the given quantity of fat in churn. So fat in churn is given as 850 kg, butter is to contain 8% salt. How much salt should be added to the churn? This is the question. So let us assume that there is 80% fat in the butter. Okay, so this means that 80 kg fat I require that how much salt is required? 2 kg salt is required for 80 kg fat. Okay, now for 1 kg it is 2 by 80, and for the given quantity, that is 850 kg, how much is it required? This will come to 21.25 kg. This way we can directly do it. No, it's very simple. So you have to assume 80% fat in the butter, and then 80 kg, for 80 kg fat you require 2 kg salt, and for 850 kg fat, how much salt is required by unitary method you can calculate. This will be 21.25 kg. Okay, this way simple way to do it. Another way that you can calculate, you can first calculate the amount of butter is there in the churn. So how amount of butter will be, say 80% of total quantity, that will be equal to 850. So this way you can have the 850 into 100 divided by 80. So this will be there, and then this is the amount of butter that has been obtained. Okay, now for it's 2%, we have to calculate. So 2% of 850 divided by 80 into 100, this will go, and again this is equal to 21.25 kg. Again this was the same way we are calculating, but just different way we are calculating. Another way to calculate, which is there given in the book itself, that you can first calculate for 100 kg fat how much salt is required, that you can calculate. So butter is to contain so if you are assuming that there is 80% fat in the butter, so for 100 kg fat how much salt is required, that is equal to 2 into 100 divided by 80, that is 2.5 kg, and the amount of salt to be added to the churn, that is equal to the if 400 kg is to 2.5 kg, for 850 it will be 850 into 2.5, that is equal to 21.25 kg. So either of the three way you can calculate, and if directly you want to shortcut formula, this you can apply, that whatever fat is given in the churn, that you multiply by fat percentage into 2 divided by fat percentage in butter, that is 80 you are taking. So that way also you can calculate. So here fat is 850 into salt 2%, and fat in butter, if you are assuming it is 80, then this way also you will have 21.25 kg. Okay, simple. Okay, now let us see the numerical of the problem number 8, which is from the chapter 4 butter, on the page number 160 to 161. Now this problem is on overrun, that percentage overrun butter. So how much more butter is obtained from the given quantity of fat in percentage, that is nothing but the overrun. So here we are given 10,000 kg of 7% milk, from that 40% cream is separated. Skim milk that is obtained is having 0.1% fat, buttermilk 0.5% fat. Amount of buttermilk is given as kg cream minus 1.2 into fat minus cream. By this equation we have to calculate amount of buttermilk. The miscellaneous fat losses are 0.5% of the total fat received in whole milk. Butter contains 80.5%, so they have given that butter contains 80.5% fat. Weight allowance is 10 gram for 1 kg pack. That means if you have 10 kg of butter, actually butter, the pack is 1000 gram. So this is 10,000 gram of actual butter. If you are having that, actually package is 1000 gram because of the packing and handling losses. Okay, now how we have to calculate how much butter is packed for sale and what is the percentage over. These two things we have to calculate. Okay, so one way we can do it in approximate calculations, also in direct calculation, the way they have asked. So let me tell you first by the method of book. So we have milk, we have milk. So milk we will have cream and skim milk, and from cream we will have butter and buttermilk. Okay, so we have to see how much fat is there in the finished butter, and how much butter is then packed for sale, that we have to calculate. So we'll start with butter fat board. Simple, it is given 7% fat. So actually fat given to us is 700 kg, that is 7 by 100 into 10,000, that is 700 kg. Simple. Now from this, how much is the skim milk separated? We are given 40% fat is there in the cream, and 7% in the milk, and then 0.1% in the skim milk. So if we see the fat equation, if we write the fat equation, that fat in milk equal to fat in cream divided by fat in skim milk, because cream and skim milk have originated from milk. So if we write the fat equation, that is 10,000 into 7 equal to, say, fat in skim milk is x, then fat in cream obviously will be 10,000 minus x. We put the value here into 40 equal to x into 0.1, because this will be the fat equation, and from this we will have x equal to 33, here 3,30,000 divided by 39.9. So this is nothing but the 10,000 into 40 minus 7, and 40 point divided by 40 minus 0.1, and this is the same equation as it is here. So just to tell you how this equation has arrived, so this can be obtained from the Pearson square also, and in this way also, if you are running fat balance equation, you will be able to know how much is the skim milk that is separated, that is x value is 8,270.7 kg, and from this, that is cream separated, we have seen that it is, we have taken 10,000 minus x, so this is 10,000 minus 8,270.7, that is equal to 1729.3 kg. This much is the cream separated. Okay, now we have to calculate fat lost in the skim milk. Okay, so since fat in skim milk is given by 0.1%, so fat lost in skim milk, that is 0.1 of 100 of the skim milk. See, fat lost in skim milk is equal to 8.3 kg. So fat that is given is 0.1%. 0.1% of the skim milk that is separated, it is equal to 8.3 kg. Now how much is the fat in cream? So from 700, 8.3 kg had been lost in skim milk. So fat in cream now will be 691 0.7 kg. Now how much is the buttermilk that is recovered? That is, here it is formula given that kg cream, you put the value of kg cream here 1729.3 minus here 1.2 into the fat and cream. So fat and cream has been obtained as 691.7. So we put this value, we'll have buttermilk equal to 899.3 kg. Now since fat percentage in buttermilk is 0.5%, so fat lost in buttermilk will be 89.33 into 0.5 divided by 100 is equal to 4.5 kg. Now miscellaneous fat losses is given again as 5%, 0.5%, so of the total fat, so this is 3.5 kg. Now so fat in the finished batter will be, so fat in cream, that is 69.1.7 minus the fat losses from the in the buttermilk plus miscellaneous fat losses, to total 683.7 kg will be the fat in the finished batter. Now this is the fat, so if we, as considering that 80.5% is the fat the butter, so if we have butter 100 kg, then from that 80.5 kg fat is there. Okay, or we in per 80.5 kg we have 100 kg butter. If we have 100 kg 80.5 kg fat, we have 100 kg butter. So if we have 683.7 kg fat, then we will have how much butter? That is equal to 849.3 kg. This is 100 divided by 80.5 into 683.7, that is equal to 849.3 kg. Okay, now how we have to calculate butter pack for sale. So as I have told you, so if we have 10 kg of gram of butter, then actually packed is 1000 gram because of the losses, handling losses. So for if we have how much butter? 849.3 gram or kg, say kg. Okay, so if we have 1010 kg of butter, then actually fat is 1000 kg, and if you have 849.3 kg of butter, bulk butter, then how much will be packed? It is 840.9 kg, that is around 1% losses will be there. Okay, now from this, if we had to calculate percentage overrun, so the butter which is obtained minus the fat was there divided by fat amount of fat which was there into 100, that will give me overrun, percentage overrun, and this coming to 21.1%. Okay, so this way we are solving this type of problem. So questions which are asked generally, they will ask that how much butter can be prepared from given quantity of milk containing percentage of fat, how much cream can be prepared, how much ghee can be prepared. Similarly, they can ask back calculation also. So if you have 10,000 kg butter, how much milk will be required? 10,000 of ghee, how much milk will be required? Similarly, if you have 10,000 kg of cream, how much milk will be required to prepare, say, 100 kg of cream? So such type of questions are also asked. These are known as back calculations questions. So this also we will cover in the coming video. Hope the question or the numerical calculations is clear to you. And most of the time when these are asked in examination, you will be provided with calculator, so you can easily solve this problem. Okay, now we will solve problem number 9, which is there in the chapters 6 ice cream on the page number 207, and this is a problem on formulation of ice cream mix. And this problem is very important and is usually asked in competitive exams and also in the written examination conducted by various cooperatives across India as a part of their recruitment process. So in this, what we are doing, we have to prepare a ice cream mix when we are given whole milk, cream, skim milk powder, and also sugar and stabilizer is given to us. And whole milk testing 6.8% fat, 9.6% SNF, cream having 40% fat and 5.4% SNF, and SMP testing 0.5% fat and 97% SNF, along with sugar and stabilizer is given to us. So we will first write the three equation. One is for fat equation. So if whole milk required is x kg, cream required is y kg, skim milk powder required is z kg. We have assumed that x y z is the quantity of whole milk, cream and skim milk powder that is required. So fat equation will be 6.8%, that is 0.068 of whole milk, that is x, and 0.40 of cream and 0.005 of SMP, that is it is 0.5%, and this total fat should come to around come to 10%, that is given for 100 kg mix. We are having this equal to 10. For SNF equation, similarly, we'll have 0.096x plus 0.054y plus 9.97z is equal to 11, and weight balance, that is x plus y will adjust, total should be 85.2, because this will be equal to 100 minus 14.5, 100 minus 14.5 plus of 0.3. This is will be equal to 85.2. Okay, because we have to remove stabilizer and the sugar from 100. Okay, now from weight balance we can find out x is equal to 85.2 minus y minus z. This is a simple mathematics. So if we put this value x in fat equation as a serum solid equation, we can have the equation in two variables. This is equation in three variables, and then we will have the equation in two variables. So after substitution, for a will become 0.332y minus 0.063z is equal to 4.2084, 4.2064, and b will become minus 0.042y plus 0.874z is equal to 2.8208. Okay, now if we multiply a, so since we have to eliminate y, so multiply a by minus 0.042 and multiply b by 0.332, so that we could able to eliminate y. So we have to remove one variable, that is y, so that the equation in one so that we can find the value of z. Okay, now since these two have become equal, so we can add, and then simply this will go like this. And if we add this thing, we will have 0.287522z equal to 1.1132. So we have added. So if you add these two, you have 1.1132, and from this we will have z equal to 3.9 kg. Now z equal to actually SMP. So SMP we have obtained as, we require SMP as 3.9 kg. And if we put this value of z in equation A, that is in this equation, if we put the value of z 3.9 here, and then we will have value of y as 13.4 kg, which is nothing but the cream, quantity of cream is required, and from value of z and y, we will have the x value, x equal to 85.2 minus y minus z. This is the equation which we obtained from the weight equation. So if you put the value of y and z, we will have x is equal to 67.9 kg with the quantity of whole milk that is required. So finally your answer is for 100 kg mix, we require whole milk has 67.9 kg, cream 13.4 kg, SMP 3.9 kg, and the sugar which is given for 100 gram, it is 14.5 gram to be added, and stabilizer 0.3 kg will be added. So total, if you add them all, we will have 100 kg of ice cream mix containing the required composition. So this way we are solving the problem. These are the problems which have three variables, and how to solve them. First, we have to convert them, reduce the equation to two variable form, and then from that we have to eliminate one variable, and finally we will get the solution of any one variable we will get and at the end, and from that we will be able to solve it to find the other two variables also.